our presentation today is about a unit circle. And a unit circle is a circle with a radius of 1, a lot of angle values, and sine and cosine coordinates that make up what the unit circle is. Okay, so these two lines touch the circle at 4 points, starting from the right, going to the top, left, and the bottom. We start at the right side, and move up counterclockwise to get to angles all the way around. Okay, to set up the unit circle, you start with these 4 angles.
You start at 0 because that is the beginning of the circle. Then you move counterclockwise.
The 4 angles that we just did divided the circle into 4 equal parts. So these are going to be divided again. So if 1/4 was pi over 2, and we divide it again by 2, we get pi over 4. And these ones are always in the exact center of the chord circle. The first one is pi over 4, just pi over 4. Next one is 3 pi over 4, and then 5 pi over 4, and then 7 pi over 4. Notice that it has a pattern starting with 1, 3, 5, 7. So it goes by 2. Okay, now let's look at the pi over 4 angles. We have the pi over 6's. So if 1/4 of the circle is pi over 2, and third of that you divide it by 3 is pi over 6. So the first over 6 is pi over 6. And then if we mirror it on the other side of the axis it's 5 pi over 6. And then 7 pi over 6. And then down here 11 pi over 6. Now we have the pi over 3's. Right here. The first pi over 3 is located right here. It might seem wrong to you that pi over 3 is bigger than pi over 6, but the thing is that remember that we're dividing by the two numbers. You're dividing by 3 here, but you're dividing by a bigger number, 6 here. So that's why it's pi over 6, pi over 3 over here. So this is actually a smaller number than that. Anyway, this is pi over 3. If you reflect it across the y-axis, you have 2 pi over 3. Down here is 4 pi over 3, and this is 5 pi over 3. Alright, this is how the unit circle is supposed to look like. Now we're gonna look at the values of each. We're talking about now the cosine, the sine, the tangents. Each of the angles that we have on the unit circle touches the circle at a point, and each one has a value. So now that every angle on the circle touches a point, and x and y point, it has an x coordinate and a y coordinate. So for this angle 0, the x coordinate is 1 because this is a unit circle, so it has a radius of 1. So the x distance is 1. And the y coordinate is 0 because the point has no height. The distance in the y axis is 0. And these two values help with finding out the cosine and the sine. The first value of where the x is located is always the cosine, while the y coordinate is always your sine. Now let's move on to the top pi over 2. The y distance is 1, and now we have 0 being the cosine, and the sine is 1, of course. On the left side we have -1 and 0 x y coordinates. In the bottom of the circle we have 0 and -1. Now we're gonna add on the values of each angle. So it's gonna go from 1/2 to the bottom, biggest, middle, smallest. Now we look at this angle right here, pi over 6. The point has an x distance as the largest of these 3 angles. So its x coordinate needs to be 3 over 2, square root 3 over 2. So we write that there. For pi over 4, for that angle, the x distance is a little smaller. So it's the middle size number, square root 2 over 2. Then for the angle pi over 3, the x distance is the smallest of the 3. So we put 1/2 for the x coordinate. And we'll be adding the y coordinates as we go throughout the unit circle. So now to fill up the y coordinates for the points, you have to use the same idea. So for the angle pi over 6, the y distance is the height is the lowest of those angles. So it needs to be 1/2, the smallest value. Pi over 4, the middle size, the y distance is the middle size, so it stays the same. And now for pi over 3, the y distance, the height is the largest of the angles.
Now that you have all the information, you can figure out the rest of the points for the angles. And the only thing that changes is you might have a negative sign. The thing you have to watch out for is maybe having a negative sign on the coordinates. Like here. Like in the first quadrant, everything was positive. But in the second quadrant, there are some negatives in the x-axis. But the y's are still positive because you're still in the positive half of the y-axis. Now moving to the third quadrant, the x's are negative and so are the y's. Because you've moved left and down. So both the x's and y's will have negative signs here.
So now that we're in the last quadrant, we moved right to the right, which makes it positive. So this is why the x is positive. And we moved down, which is why the y is negative, because it's on the x and y axis, the x being the positive side, the y being the negative.
To remember is the whole time that we're working in the radian angles, all the angles like pi over 6, like those are the radian angles. So you may need to work in the degrees too, and all of them have a corresponding degree angle. You might already know that pi is 180 degrees, so that would mean half of that. So pi over 2 is 90 degrees. So here are some examples of equations that can be solved using the unit circle. So for the first example, there's sine 45 degrees. And this problem is pretty self-explanatory if you pay attention in pre-calculus. So if you look at sine 45 on the unit circle, you see that the coordinate is root 2 over 2 and root 2 over 2. But you have to remember that sine on the unit circle means y, so for the answer you put the y coordinate, and that would be root 2 over 2. So for the second example, there's sine x equals cosine x. And there are many ways to solve this equation. So when using the unit circle, we want to find where the y coordinate is equal to the x coordinate, because you have to remember sine theta equals y and cosine theta equals x. So by looking at the unit circle, you find pi over 4, and you can see that the coordinates are equal. So then that means sine theta and cosine theta are equal. Also, if you look at 5 pi over 4, the x and y coordinates are equal here too. So the solution is x equals pi over 4 or x equals 5 pi over 4. So just remember the patterns, because the patterns will make it faster and easier to learn.